Assalamu alaikum everyone. Welcome to the 12th tutorial for probability. My name is Munif Rizvi. I hope all of you are doing well. First of all, Ramadan Mubarak to all of you. I hope the day goes well and hopefully the subsequent month for you as well. With regards to this tutorial, the key things to notice is that we want you to prep for the final quiz that we have on Monday, and with that we're mostly covering questions related to correlation, covariance, not correlation, mostly covariance and conditional expectation as well, right? So you'll find some of the questions that we do at the start a bit easy, but the more the idea is you want to get done with the range of questions that might help you in the quiz, and that is why we've covered a diversity of topics, so to speak, in terms of the content we've learned in these two in the last two lectures. So we'll start off with the first question. It seems pretty easy. A fair die is rolled 10 times. Calculate the expected sum of the 10 rolls. So I can define an event as X being the number of, like the number you get on the die. Number on the die, right? So at your ith turn, right? I can denote this as I, and on the ith turn, right? Now the thing is, if I for any sort of number that I have, what can be the probability of that number appearing on a die? That will be what? 1/6, right? Regardless of whatever number I pick, because it's a fair die, it'll be 1/6. Now, usually the idea is, how do I find the expectation of, like, if there's one row, right? The format is, if I have the number k, right? So it will be k into the probability of me getting k, right? So in this case, if it's 1, it will be the number 1 multiplied by, what's the probability of me getting a 1/6. Likewise for 2, it will be 2 in wrong, 2 into, again, 1/6, because the probability is the same. This will continue until I have sort of my last term, which is 6, and into the probability that is 1/6. So I can denote this as, if I take 1/6 common, I can denote this as 1 plus 2 plus 3 plus 4 plus 5 plus 6. Now this is what I think 11, 15, this is plus 11, 15, 18, 20, 21. So that is 21/6. That is the expectation of me, like that's the expectation of a fair die for one row, right? For 10 rows, essentially you have to multiply the expectation with the number of tries that you have. In this case, it's 10, so it will be 21/6 into 10, right? And that will be your answer, 35. Note how this is the expectation of one row, right? This is EX particularly. If I divide this as, well, essentially I can, if I have to be very specific about this, EX is basically one row, and EY is the expectation for 10 rows, right? This is EY, this is EX, right? So that's the only thing you have to be careful of. Otherwise, there's nothing much more to this question. This is just a starter question to get you sort of in the motion for it, right? So I'll move to the next question. So suppose that A and B each randomly and independently choose 3 of 10 objects. Find the expected number of objects chosen by both A and B. So what's the probability? They're saying it's the same. Essentially, both have to pick 3 out of 10, right? They both will have the same probability. So PA can be 0.3, and that'll also be the case for PB. Now I have to find PAB, right? Both A and B. Because they mentioned that this is independent, note independence in this case is important, because I can separate this as PA into PB, and hence why this will become 0.3 into 0.3, which is 0.09. So part A is pretty easy, right? Now part B is saying not chosen by either A or B. That is again simple. If P is 0.3, P A dash will be, or P A complement will be 0.7. So 0.7 into 0.7 that is 0.49. Again, very simple questions. Now, part C says, find the probability, find the expected number of objects chosen by exactly one of A and B. Now, one of A and B can either imply P A and B complement, or it could imply P if a complement into B, right? So, solely तौर पे because the probabilities are the same, I can denote this as like the general form, right? So this can be 0.7 into 3. And because they're the same, I just need to multiply this by 2. And that will be what exactly? That will be 0.21. No, wait, that will be 0.42. I forgot to multiply by 2. That will be 0.42. Right. So I just realized I made one mistake. All I've done is right now, I've just denoted the probability, but the question says find the expected number, right? So I'll go back to part A. Essentially, I just have to multiply it by 10 because 3 of 10 objects, right? The number of, the total number of trials one will take will be still be 10, right? So based on that, I have to multiply everything by 10. So this will be multiplied by 10. Again, this was the probability multiplied by the number of times. That's 10, which will be what? 0.9. The expectation will be 0.9. Here it will be multiplied by 10. It will be 4.9. And here multiplied by 10, it will be 4.2. Note the mistake I made was that I only denoted the probabilities. I did not find the expectation. And for that, I just had to multiply by 10. Okay. Seems simple enough. So I go to question 3. I think now where the more important questions will come in terms of computation wise, because you'll have to move fast considering the fact that these might be long questions. So the first one is, let x be the number of ones and y be the number of twos that occur in n rows of a fair die. Compute covariance. Okay, of the two. Okay. So first of all, the general formula of covariance that I know of is, give me a sec, EXY minus expectation of x multiplied by expectation of y. That's the formula. So I need to find all of these terms. Now, how have they defined x? X is basically the number of ones I get in n rows of die. So it can be, I can define all the sample space of the events for x as x1 plus x2 plus xn, where basically the small x denotes the result of that particular ith or the particular kth roll of that die, right? So basically this implies the number of ones. The sum of this will denote the number of ones in that I've gotten in n rolls. Likewise, capital Y will be y1 plus y2 plus yn, and this will be the number of twos in n rolls of die, right? Now, in this case, for every xi or every yi, this ith value will be 1 if I get the number 1, right? If the ith roll is 1. And likewise, yi will be 1 if if the ith roll is 2. Okay. So I just wanted to clarify the terminology here so that I know what to compute. I've denoted how I can get capital X. I denoted how I can get Y with the expression that I need to compute for n rows of the fair die. Now, is there a possibility where I can denote Xi and Yi? Like, is there a possible value that it can take? In my mind, I know for a fact that this has to be 0. This cannot be possible at all because ये एक डाई रोल हो रहा है ना, और एक डाई के रिजल्ट पे हम बता रहे हैं कि क्या है. अगर एक आई पे you can either get a 1 or you can get a 2. You cannot get both, right, at the same time or at the same ith roll. So I know for a fact that xi yi, or like the probability of xi yi has to be 0. So this implies that the expectation of xi and yi is 0, right? So I've figured this out. Now I have to figure out EX. Now EX, I think I can compute it, right? So what is the what is the expectation of X, capital X, not small xi, right? That will be 1 upon 6, right? QK, if I have a fair die and I roll, if there's 6 numbers in that die, the probability of me getting 1 is 1 upon 6. Similarly for Y, it will be 1 upon 6. Just my bad, this is xi, because this is for one die, right? For any one roll of that die, what is the probability I can get as xi yi, right? So first I'm going to denote this as xi yi, and then I'm going to convert this into n. So exi yi minus exi EYI. Apologies for the lack of space. So this I've denoted this as 0. I've already figured that out. This is 1 upon 6 multiplied by 1 upon 6, right? Now, this is minus 1 upon 36 is the covariance for any like particular roll of die. Note in this case, to be careful with terminology, I'm going to write this as I and J, and here as well as I and J, just to denote the fact that they have to be different roles, right? It might be the third and the fourth row, role, or the 23rd and the 27th role, right? I don't care, but what I have to note, because that I and I can never be the same value in this case, they're different, right? In terms of notation right now, I'm still going to denote this as I, but the reason for that is I am strictly saying that they can't be the same value, right? Xi and yi can never be, like, they can't happen at the same time. So this is minus 1 upon 36. Now, because I have to convert this into the all possible values of n, right? There are n possible values. So if I need to convert this into covariance of x and y, this will be minus 1 upon 36 into n. And that will give me minus n upon 36. That will be the covariance. This may seem confusing, but the only thing you need to note is, is there a possible way is there a possible way where you can denote x and y? And the answer to that is absolutely not. You can like for the case is x I and y I can never be the same. So in that case, the expectation has to be 0. But if I have to denote them as separately, like EXI में अलग calculate कर रहा हूँ और EY में YI में अलग calculate कर रहा हूँ, तब there will be a expected value associated to it, and that is 1 upon 6, right? So in this case, please be careful of the notations. It will still be sort of XI and YI, right? Just be careful of that. Right. Again, if there's any confusion, we can go over this like in my office hours, right? So I'm going to move on to the next question. Now, this is a question I quite enjoy, Vasa. So the question says, if x and y are independent and identically distributed, and they've given you the mean and the variance, find this expression. Now, this is a question that I think Sir has covered this in his lectures as well. Not this particular question, but the concept on how to sort of expand this, right? Now, if I have a quadratic inside this, I first need to find as simple of an expression as I can for it, right? So first I'm going to do is I'm going to expand what's inside. Like, because it's a quadratic, I can expand this. So I can denote this as x square minus 2xy plus y square. Now, because they're identically distributed and independent, I can sort of separate this, right? I don't know why my pen is not working. Apologies. So I can separate this as ex square minus 2ex ey. I've separated this because x and y are independent, plus e y square under, right? Now, is there a formula I know that can associate, or I can convert ex squared to something in terms of a mean and a variance. And I think the variance formula does help in this case. What is the variance formula? The variance formula basically says that it should be ex square minus ex whole square, right? So if I make this the subject, so I can denote ex square as variance plus expectation whole square, right? So my new expression will now become variance of x plus expectation of x whole square, right? Minus 2ex is, again, we know that. We also know expectation of y, we will leave it as this. And the same case with ey square, that will be variance of y plus expectation of y whole square. Now, because they've said that x and y are independent and identically distributed with mean, mu, and variance sigma square, both of them will have the same parameters. So I just have to input this, right? So this will be sigma square, this will be mu square, this will be minus 2 mu into mu, right? Mu into mu plus sigma square plus mu square. So this and this cancels out. Mu square minus 2 mu square plus mu square, yeah, that cancels out. So this will be 2 sigma square, right? So overall, this term can be simplified into this one, only because of the fact that I can separate them, because one, that's the rule of expectations, where you can separate out variables, like in this one, that the way I've done this, and I can separate two variables if they're independent in this form, right? Like x and y can be converted into expectation of x into expectation of y if they're independent. Okay, so moving to the next question. So this may seem easy, but I think the last part was a bit long, so I thought it was necessary I had to do it. So a fair die is successively rolled. Let x and y denote respectively the number of rolls necessary to obtain a 6 and a 5. Okay, so find the expectation of x. So x is, okay, if I need a 6, right? So what they're trying to say is I will roll a die multiple times until I get a 6. So, and if it's n tries, that means for n minus 1 tries, I'll have a failure. And in the nth trial, I'll have a success. So that's a geometric distribution, right? So I can, if I need to find the expectation, this can be denoted as a geometric distribution, right? I'll write this here again as like you have n minus 1 failures and you stop until you get your first success. That is at n. So what's the expectation of a geometric variable? That is 1 upon p. What is p? P is basically the success of, like, the probability of you getting a success, because it's a fair die and you need just one number, that would be 1 upon 6. So 1 upon 6, that is 6, right? Part A is pretty simple. Now in part B, they've said that find the expectation of x given y is equals to 1. Now what this basically does is they fixed you a value of y, like you won't change that. All you have to do is find the expectation of x corresponding to that fixed value of y. And how I'll do that is, what they're saying is, if y is equals to 1, that means you got a success in your first try. So what's the expectation of your first trial? 1. Reason being, क्योंकि और कोई possible ही नहीं, they fixed one variable for you, and that is y, and that is the first roll. There is no possibility where you might get an x on that try or before that try, right? There's no permutations that can be changed up until that point for your, until you get your first क्या कहते हैं, success with y. right? Because it's the first try, I'll fix that as sort of y. Now, if I figured out at what point will I get a 5, or that in that case a success for y. Now I have to figure out how I'll make the distribution for x. Now, क्योंकि एक हो गया अब बाकी possibilities खाली x की हैं. So now essentially what I have to do is now the fail, I don't know कि अब success का point कब आएगा. It can be the second try, who knows, it can be the 5th try, it can be the 7th try, I don't care. Crucially, what's important is it should start from the second try. And because again the same case applies, it's a geometric sort of distribution, I can denote this as 1 plus ex because I don't care what happened before. All I have to figure out is, because the probability will still be the same, all I have to figure out is what will be the expectation for x. So 1 plus expectation of x, in which this is like the first trial. First trial in which you got, in which it is fixed that you have again a y, or basically a 5, right? So 1 plus ex, I've denoted, I've already know what ex is, that is 6. So 1 plus 6 is 7, right? Seems simple enough. I would like to again add, there's only one possible scenario in this case, in which you first get a y and then you figure out what will be the permutations for x in this case. Again, after the first row, we again want to calculate the number of rows to get the first 6, which in this case is geometric variable. Now, part C is where you will understand why I'm sort of elaborating so much on this. So part C says find the expectation of x given that y is equal to 5. Now there are multiple cases, not one, not multiple, mostly two, right? That we have to keep in mind of. Firstly, they've told us that in the 5th try, 4, 5, yeah, this is the point where you get a success for y, or where you get a 5, right? So this point is fixed. I don't need to worry about this. Now, I don't know when I got a 6. It could be here, it could be here, or it could be again, well, I don't have a color. It could be here as well, right? The cases here are different because in the sense that if you already know that the first time you get a 5 is at trial number 5, that means for the previous 4 tries, you know you will not get a 5. And what effect it has on 6 is that the probability of you getting a 6 now will increase. Because pehle to ye tha, it was 1/6. Out of 6 possibilities, you could have gotten, like there's only one time, like there's 1, 6 and like 6 values. Now you only have 4 values left, right? That could not be a 6. So essentially now, if you want a 6 before the 5th trial, it will be 1/5 and not 1/6, right? I'm going to denote this event as A, right? A is basically the event that you get a 6 before the 5th trial, right? Now, again, after the 5th trial, मुझे पता है इसकी तो 5 value fixed है. अब बाकी cases में क्या होगा? इसमें तो फिर वापस से 5 आ जाए, I don't care. So again, for me to get a 6, the probability will be again 1/6. Now, how do I denote this in terms of an expectation? Right? पहले मुझे ये बताएं कि what's the probability of me getting the number 6 in the first 4 trials? Right? It's pretty simple. It will be 4/5. I will denote this properly. Give me a second. Yeah. So what I'm trying to say is, find me the probability of the event that you get a 6 in the first 4 trials. I am just doing my working here just to make sense of things I might use later on. So an accumulated sum of me getting a 6 in the first 4 trials, because they're independent, it will be 4/5 to the power 4, क्योंकि पहली बारी में 4/5 होगा into दूसरी बारी का 4/5, that's I get 4/5 into 4/5 into 4/5 into 4/5, right? So वो हो गया, so that's 4/5 to the power 4. Now अब मैं I'm gonna try to get into the specifics of x conditional y is equals x given y is equals to 5. Now पहली बारी का देखते हैं, ठीक है, of me getting like पहली ट्रेंड में देखते हैं क्या होगा, एक्सपेक्टेशन क्या है, n क्या है, n की वैल्यू क्या है 1. Now what is the probability of me getting a 6? Again I have to make the distribution for x, right? What is the probability of me getting a 6 in the first trial? That's 1/5, right? Again, not 1/6. Do I have to worry about what's the probability of me getting a 5 now? I don't, because I know for a fact that the first y will come in the fifth trial. So I'm not worried about y. I just have to care about 6, right? Now in the second trial, okay, so in the second trial, n is equals to 2, तो ये तो value यहीं रहेगी. What is the probability of me getting a 6? That's 1/5. Now crucially, what is the probability of me getting of me not getting क्या कहते हैं a 6? That's 4/5. Again, note के you know how distributions work in which you have k minus 1 trials and you have I and n minus I. This is that distribution that I'm trying to make, right? So in the first trial I don't care because naturally I know for a fact that I will get क्या कहते हैं a 6. So in the second trial there is a possibility of me getting क्या कहते हैं a 6. Actually, I need to clarify one thing. I made a mistake here. When I said event you get a 6 in the first trial, this is not me of the event that I get a 6, because that would be 1/5 into to the power 4. What I also like to add that is that what's the probability of the event that you do not get a 6 in the first 4 tries? That will be 4/5 to the power 4, right? So please be careful of this transition. The probability of the event that I get a 6 in the first 4 tries, that's 1/5 to the power 4. The probability of me that I do not get a 6 in the first 4 tries, that's 4/5 to the power 4. Again, I apologize for the inconvenience, right? So in the first trial, I'm back to, in this case now, in the first trial, I know that I'm not gonna get a 5. It has to be like a 6, so that's 1/5. Now, likewise, I'm gonna continue this trend. This will be 1/5 again. This is the third trial, and this will be 4/5 to the power 2 now, because in 3 trials, what is the probability of me getting क्या कहते हैं, what is the probability of me getting not a 6, right? That can be the case, so that will be 4/5. Now the other thing I have to be careful of, I'm going to continue with this distribution. This is 4 into 4/5, sorry, 1/5 into 4/5 into the power 3, right? Now this will continue on. Achha. Now for the fifth trial, I don't care, because I know it's a fixed value. There is no probability associated with the expectation will be 1. That is the fixed condition that I have. So now I have to worry about cases in which I've gone past the fifth trial. Now it's the sixth trial and the seventh trial. So I'm going to try to make like a consolidated sort of statement for it, right? A summation of it. So this consolidated statement will start from the 6th value, and this couldn't go till infinity, right? Because they haven't given us a cap on the number of trials we have. So this has to go from 6 till infinity. Now, expectation में होता है you multiply it by the term that you have. तो k तो आएगा हर हालत में, right? Now, what's the one thing that's fixed? Okay, I know for a fact that I do not have a 6 in the that there is a possibility that I do not have a 6 in the first 4 trials, and that because I calculated this here, this will come to my advantage, and I know that this has to be 4/5 to the power 4. Again, because अगर मिसाल के तौर पे मैं इस value का associate कर रहा हूँ, I cannot ignore the previous 4 values that were there. So there is a possibility where I do not get a 6 in any of those 4 tries, and to denote that probability, that will be 4/5 to the power 4 and multiplied by like, now because you have to cater to this side, what is the probability that you not get a 6 in that particular trial? That is now crucially 5/6, because you can get a 5 again, so you have to adjust that there, and that will go from to the power k minus 6, right? Because आपकी ये वाली value है ना, यहाँ से शुरू हो रहा है, so it can, again, if it's your 6th trial, so it will be 0, right? कोई possibility नहीं of you not getting a 6 now, right? So I hope that makes sense. Multiplied by now the new probability of you actually getting a 6, and that will be 1/6, right? So usuli taur pe, this consolidated statement is your expectation answer. I doubt Sir will test you on something as comprehensive as this. This can be a good homework question, but I doubt that you might be tested on this. But the concept is very important on how you make sort of conditional expectation key sort of sequence particularly. I hope that was clear. Again, if not, we can go over this in my office hours. But what you need to note is the probability of you getting a certain success versus the probability of you not getting a success over previous 4 trials, because again, geometric distribution. The reason I did this is because of the geometric distribution, okay? And I want to make one thing evident again. The reason why we have not put 4/5 here is because you know the geometric formula that k to the power n minus 1 into sort of p. That is why we've done this, right? Again, geometric distribution basics. So I'll move on to the next question. And I think this is the last question. So the question has given us a joint density function, and we need to compute this. As I mentioned before, that if they fixed sort of this value for you, right? This basically implies that you're going to fix a particular value of x. Sorry, you're going to fix a particular value of y, and then you're going to integrate this throughout x, all possible values of x. So x, they define the range 0 till infinity, and I'll multiply this by x square, because question mein the condition is x square and not x. So x square into fxy, not fxy, balki condition y is equals to 1, right? And now dx into, because we're integrating this with respect to x. One thing you should notice, this will not be x and y, this will be x conditioned y. And another thing is it will not be x square conditioned y, it will be x given y. जो x square part होता है वो हम यहाँ पे इसको cater कर देते हैं. Now, how do I expand this? Because it's an x condition, conditional expectation, I need to convert it into fxy, right? What's the formula that I know? Fx given y is equals to fxy upon fy, right? So I know fxy is given here. Now this is done. I need to calculate this. How do I calculate fy given I have fxy? I will integrate out x for me to get f of y. So fy is equal to 0 till infinity, because that's the limit, into fxy, which is e to the power minus x upon y. E minus y is by minus y upon y and dx, right? Integrating out x. So e to the power minus y and the denominator y, they're constants, right? So I can take them out. So this will be e to the power minus y upon y, and I'm going to just integrate e to the power minus x upon y. Like I said before, y is a constant, so integrating e to the power minus x upon y, that will yield us minus x upon y, right? तो इंटीग्रेट करना है, जो फ्रैक्शन है वो क्या कहते हैं डिवाइड होगा, सो यहाँ पे आपको आ जाएगा माइनस वाई, अगेन माइनस वन अपॉन वाई डिवाइड होता है तो माइनस वाई आ जाएगा न्यूमरेटर में, एंड e to the power माइनस एक्स वाई विल रिमेन एज इज, और उस पे हम लिमिट्स डालेंगे 0 till infinity, right? What this will give us, you can do this as an exercise for yourself. अच्छा ये तो पहले जिस by the way ये तो वैसे ही कट रहा है, and I think this gives us 0, or no, this will give us 1, I'm not sure. Yeah, 100% 0 or infinity अगर limits होंगी, so an expectation minus expectation will give us 1. So I think this will be minus e to the power minus y, no, plus e to the power minus y, because yeah, I think minus देगा with these limits. You guys can check if you want. I've confirmed this with my answer as well. It's e to the power minus y, right? Now, the only thing I've done so far is I've calculated fy. Now, I am going to input this into the equation. Now, I know for a fact that x given y is e to the power minus x upon y, ey upon y into e minus y, right? Also ये तो कट रहा है, तो इसकी वजह से it will just be minus x upon y, right? So that's x given y. So what's the other thing now I have to do? I have to basically find this term, right? So inputting this into the original equation here, so this will be 0 till infinity x square e to the power minus x upon y, that's my new term, and integrating this with respect to x. So again, taking out the constants, this will be 1 upon y, 0 infinity x square e to the power minus x upon y. I know for a fact I can solve this using integration by parts. We can do this again, like u is equals to x square, u dash will be 2x, v is equals to minus x upon y, and v dash will be the integral, which is minus y e to the power minus x upon y, right? So I'm going to input this like in the integration by parts wali equation, which will give us 1 upon y, the constant तो वो तो वैसे ही बाहर होगा, so this will be x u v dash, which is x square into minus y e to the power minus x upon y, and I think that's it. So इस पर limits डाल देंगे 0 till infinity. Now minus integral from 0 till infinity of u dash and so इसको मैं v star कहता हूँ मैं, u dash and v star, which is minus y, no wait, 2x minus y, 2x into minus y e to the power minus x upon y dx. So if you guys want to calculate this, you can as an exercise for yourself. I have the luxury of having the answer right in front of me, and the answer I'm getting here is this. So based on this answer, I think what this implies is कि ये तो 0 होगा, तो उसकी वजह से जो ये term है, that is essentially what they've written here. I'm assuming that is the case. No wait, I forgot to add a y. Yeah, ये पूरी term अब यहाँ आ गई है. अच्छा, it also makes sense क्योंकि minus minus से plus हो गया, तो 100% this term will be 0. अब यही term आ गई है. अब solving this further, if I integrate this, this will be again 2y. I think we solved this by integration by parts पहले भी, so it should be pretty simple. So अब पहले x square तब x है तो और आसान हो जाएगा. So this will give us 2y minus y e to the power minus x upon y, और इस पे लिमिट्स लगेंगे 0 से infinity तक, which again I have the luxury of having the answer, which will be 2y square. I hope that's clear. So essentially, questions like this will come probably in the quiz. The idea is you usually people spend a lot of time in the computation, but and the idea is it's just basic computation. I won't say basic, but it's still computations that can be easily done. The important thing to note is how to convert this term into this, and the rest will just follow, right? So if you know the terms and how you convert an conditional expectation into fxy, how you can find all of these terms, how you can integrate one variable out, integrate out one variable to get a certain term. These are the things that we've covered extensively in this course, and I'm pretty sure you all know them very, very well. So I think hopefully this quiz will go very well for all of you, inshallah. So pretty much that's it. Again, I am going to stop the recording now. If you have any questions, please let's go over this in my office hours later tomorrow. Again, thank you again for the tutorial. Please take care. Khuda Hafiz, everyone.